Game Theory Assignment Help. For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@economicshomeworkhelper.com or reach us at https://www.economicshomeworkhelper.com. 1. Alice and Bob have inherited a factory from their parents. The value of the factory is VA for Alice and VB for Bob, where VA and VB are independently and uniformly distributed over 0, 1, and each of them knows his or her own value. Simultaneously, Alice and Bob bid BA and BB, respectively, and the highest bidder wins the factory and pays the other sibling's bid. If the bids are equal, the winner is determined by a coin toss. Find a symmetric, linear Bayesian Nash equilibrium of this game. 2. An object is to be sold to one of n bidders through a first price auction. The value of object for bidder I is 6 greater than or equal to 0, which is privately known by the bidder I. The values V1, Vn are independently and identically distributed with probability density function f and cumulative distribution function f. Write this formally as a Bayesian game and compute the symmetric Bayesian Nash equilibria in increasing differentiable strategies. Economic applications of game theory. Problem: increasing differentiable strategies. 3. There are n hunters. Simultaneously, each hunter chooses between stag and rabbit. If a hunter chooses rabbit, his payoff is theta regardless of what other hunters do. If he chooses stag, he gets V greater than 0 if at least k other hunters also choose stag, and gets 0 otherwise. The possible values for theta is A, B, where A 0 and B greater than V. A. Assume that theta is known and compute the set of pure strategy Nash equilibria. B. Assume that theta is not known. Each player I observes a signal. 11 equals theta plus epsilon eta, where 0 epsilon min, minus A, B minus V, and eta 1, eta n, are independently and identically distribute with uniform distribution on -1, 1. Find the set of symmetric, monotone Bayesian Nash equilibria. That is, find the possible values for a cutoff x** operator such that each player I chooses stag if and only if 11 less than or equal to x** operator in equilibrium. Economicshomeworkhelper.com. Hint: by symmetry, the probability that 11 is the mth highest among x1, xn is 1/n. Briefly discuss your answers. 1. Alice owns a car, and Bob may buy it. The car can be a lemon or a peach. Alice knows whether it is lemon or peach, while Bob assigns probability 1/2 to each case. The value of a lemon is $1,000 for Alice and $3,000 for Bob, and the value of a peach is $5,000 for Alice and $10,000 for Bob. Alice sets a price P as an element of P, and Bob decides whether to accept the price. If the price is accepted, they trade the car at price P. No trade occurs otherwise. For each set P below, find a sequential equilibrium and verify that it is indeed a sequential equilibrium. A. P equals 2,000, 7,000. B. P equals 0, infinity. Economicshomeworkhelper.com. 1. As we are looking for symmetric BNE, suppose that in the equilibrium both players play bidding strategy B, that each type Vj bids B, Vj, for some increasing differentiable function. From player I's point of view, if he bids buy, his expected payoff is, given that the other player follows Bj equals B, Vj. Taking FOC with respect to buy, we get. This must be satisfied at buy equals B, 6. Thus we have solutions. This must be satisfied at buy equals B, 6. Thus we have Bj, 6, 1 minus 6, minus B, 6, plus 6 minus B, 6, equals 0. In particular, we are looking for linear BNE. Let B, 6, equals V plus beta. Using this, we have 1 minus 3 alpha, 6 plus alpha minus 2 beta, equals 0, so alpha equals 1 and beta equals 1. Thus, the symmetric linear BNE of this game is B6 equals 1 6 plus 1. 3636 comment: the professor made an announcement at the lecture that this game is not a second price auction as the winner pays the other siblings bid to him/her, so if you lose, you get what you did bid. In case you did not interpret the question in this way, and reached the conclusion that bidding one's own value is BNE, I gave half points, 5 points, assigned for the problem. 2. Writing as a Bayesian game. economicshomeworkhelper.com. Otherwise. Types: individual values, are I'd with PDF-F and CDF-F. Computing the symmetric BNE in increasing differentiable strategies. Suppose that in the symmetric BNE all players play bidding strategy B, that Bj equals B, Vj. From player I's point of view, if he bids buy, his expected payoff is, given that all other players follow Bj equals B, Vj. N equals 1, 2, n, t equals 6 tilde operator f, ai equals by is an element of 0, infinity, payoff is 6 minus by if when the auction and 0. Taking FOC with respect to by, we get. Substituting by equals B6 as at the optimum, player I should also play bidding strategy B, we get. We can rewrite this as integrating both sides, and since B6, F6, and minus 1 equals 0, when 6 equals 0, if value is 0 you bid 0, we get. economicshomeworkhelper.com. Using integration by parts, we get. Comments: do not forget to write this as a Bayesian game, as those are easy points at the exam. I did not take points off for this set grading, but if it were the exam, if you missed this part you could have lost 20 to 40% of the points for this problem. 3a. If theta 0, the only equilibrium is to play stag. If theta equals 0, there are equilibria where any number of players between 0 and k-2 play stag, and where everyone plays stag. For 0 theta less than or equal to v, the equilibria are everyone plays stag, and everyone plays rabbit. In addition, if theta equals v, there are equilibria where any number of players between k and n play stag, and the rest play rabbit. If theta v, then everyone plays rabbit is the only equilibrium. B. There will be one monotone BNE. The value of stag is decreasing in 11, and the value of rabbit is increasing in 11. For a given x** operator, there will be one x that is indifferent between stag and rabbit. This x must equal x** operator for this to be a NE. X is monotone increasing x** operator, so there will be one BNE. To find that BNE, consider some x** operator. If 11 equals x** operator, then he is indifferent to stag and rabbit. He has expected value of x** operator when playing rabbit. His expected value of playing stag is VP, xj. X** operator for k players. By the hint, the probability that k players have lower xj than our x** operator is 1 minus k/n, so our expected value simplifies to v, 1 minus k/n. Thus, for 11 equals x** operator to be indifferent, it must be x** operator equals v, 1 minus k/n. economicshomeworkhelper.com. 4a. In equilibrium, A picks P equals 7,000 after peach, and P equals 2,000 with probability 1/4, P equals 7,000 with probability 3/4 after lemon. After seeing 2,000, Bob believes lemon with probability 1, and after 7,000 Bob believes lemon with probability March 7th and peach with April 7th. These beliefs are derived from Bayesian updating. After 2,000 Bob accepts, and after 7,000 Bob accepts with probability 1/6. Bob is indifferent between accept and reject after 7,000 because he has expected utility 0. And Alice is indifferent between 2,000 and 7,000 after lemon because he has expected utility 2,000 in either case. To see consistency, consider theta m equals 1 minus f, 7,000 plus f 2,000, 0.25, 2,000 plus 0.75700.